Hello everyone, welcome to Pepcoding. In this video, we are going to look at the question search a 2D matrix. Okay, so let's take the question statement from here. Okay, so this is my question statement. Now let's see. In this question, I have a matrix and it is already sorted. So what does it mean? That if I write the values like this, if I write all the row values of this and then I write the row values of this, I would get 1, 3, 5, 7, 9, and then 10, 20, 25, 29, 34, then 38, right? So all of these values are sorted like this, right? They are going like this. So it is traveling like this. Then from 9, it is jumping to 10, right? And then it is going like this. Then from 34, it is jumping to 38. So something like this. Okay. And I have to check. I have to see that if, let's say I have a target 24, right? I have to find this target. I have to find this target in my matrix. Now, what is going to be my brute force approach? Well, if I have to find something in my matrix, I can just check for every element, right? But if I want to check for every element, that would be in the complexity of O of n square, right? Because I'm going to traverse every element. So the better approach would be to use binary search, because I know that all my elements are sorted, right? And if my elements are sorted, can I use binary search on it? Right? If I'm trying to find some target in a sorted array, I can just use binary search. But instead of a sorted array, we have a sorted matrix. Okay, so let's see the approach that we're going to use. We're going to do two major things. Okay, so what is the approach? We're going to do two things. The first thing that I'm going to do is try to find possible row. Try to find possible row. What does it mean? Well, my target can lie anywhere from 1 to 192, right? But if I know the row only, if I know the row in which I have to search, then I won't have to check on all of these values, right? Let's say this was a very large matrix, right? This was like this. It was a many there were many rows and columns, right? It was a very large matrix. Now it might be efficient to solve this, if it might be efficient to just traverse this whole array, but for a very large matrix it is not very feasible, right? So for this, if I just know the row in which I have to sort or in which I have to search, instead of having like this range, I can just have one row in which I have to search for that target. So I'm going to use this approach where where i'm going to find where I'm going to find the possible row in which my target is going to lie, right? What do we mean by that? So in this question, you can see that my target is 24, right? My target is 24. Then my target cannot lie between 1 and 9, right? I know that. My target cannot lie between 38 and 53. My target cannot lie between 60 and 74 because they are sorted, right? They are in ascending order. So my target can only lie in my first row. So if I apply a binary search here, if I apply a binary search on my matrix and I find the possible rows, right? I can get the possible row in which my target is going to be present, right? I hope you understand this part, that we are trying to find the possible row in which my target is going to be present. I'm not trying to find the actual column or actual block in which my target will be there. I'm just trying to find the row in which my target will be present. Okay, so I'm just searching for the row only. So the first thing is I'm going to try to find the possible row, and the second thing is, if I know the possible row, let's say my target was 44, right? If my target was 44 and I know that my possible row is 2, then I can just use a binary search on this row itself, right? Binary search or try to find possible answer in that row. Right? So if I know the target, if I know the target and I know the possible row in which my target is going to be present, I can just use a binary search on the row itself. So let's try to see this for target 24. Right? I would have a low here, I would have a high here, and I'm applying a binary search on this matrix and I'm trying to find the possible row. Okay, this is nothing. Let's just keep it like this. Okay, so we have low and high. My mid is going to be 2, right? Low is 0, high is 4, and my mid is 2. Okay, 0 plus 4 by 2, right? So mid is also, let's write this. Mid is low plus high by 2, right? So this is 0 plus 4 by 2, which gives me 2, right? So this would be my mid row. Now, is my target going to be present in this mid? How are we going to check that? If my target is greater than 38 and my target is less than 53, if I know that if my target is greater than 38 and my is less than 53, then I can say that it is the possible row, right? Let's say I have 24 and I'm going to search for this mid, right? If let's say this was the mid of my uh, array, and if I search for 24 in this mid, am I going to find a possible row? Right? This won't be a possible row, no? Because this is starting from 60 and my last value is 74, right? So which means that my possible row is going to be on the low end side. I hope you understand this part. Like we did in the binary search of a normal number. Let's say we had, let's take this row only: 60, 61, 65, 68, and 74. Right? If we performed a binary search here, we had low and we had a high, and we searched using the mid. Right? This was my mid. And we searched that if my value is on the right hand side of mid or on the left hand side of mid. That is what we were trying to achieve in the binary search. That we are doing the same thing, but the checks we are going to make is that if my target is going to be present between the smallest value of that row and the largest value of that row. If I know the range, right, I can tell if my target is present in that range. So for target 24, I can say that in this mid from 38 to 53, my target is not going to be present. So I'm going to search on the high minus 1, or mid would, my next mid would be, or high would be mid minus 1, right? My target is going to be on the above hand side, right? It is going to be on the upper hand side of that mid. So I'm just going to decrease my high as mid minus 1. Okay, I hope you understand this part. Now for this, my new high would be here, right? If my high is 1, then I would have my new mid as 0, right? Because mid is 0 plus 1 by 2. It gives me 0, right? 1 by 2 is 0 0.5, and the answer of integer is 0. Then my new mid will be this, right? 0th will be my mid. And for my this mid, I will check that if my target is in between my range, which is the smallest value of that row and the largest value of that row, the 0th index and the last index. If I know that it lies between my range, then I'm going to check. Then I'm going to say that it is a possible row. If it doesn't lie in that range, I can just increment my row, right? I can just say it is my now new low. My new low will be mid plus 1, because it is always going to be on the below end side of my current row, right? We're doing the same thing we did for a binary search, that if it is on the left hand side of my mid, my mid would be, or my high would be mid minus 1, right? And if I said that it is going to be on the right hand side of my mid, I would say that it is low. My low would be equal to, let's say here, My low would be equal to mid plus 1. This is mid minus 1, my bad. Right? My high is mid minus 1 and my low is going to be mid plus 1. My low is going to be mid plus 1 if my value is going to lie on the right hand side, and my high is going to be mid minus 1 if it is going to lie on the left hand side. But if I take the same thing and if I rotate it some way, right? If I take this same thing and I try to rotate this like this, right? We are doing the same thing here only. Right? You can see, or let's do it like this only. Right? It is going to be on either on this side or on this side. And I'm checking for my rows. So if it is on the above hand side, then my high would be mid minus 1. And if it is on the below hand side, my low would be mid plus 1. Okay. So I know the possible row using this approach. My low would be here and my new mid would be this, right? This would be my new mid. So for this mid, for the first row, I would have 10 and 34 as my range, right? This is my smallest value of this row. This is my largest value of this row. My range would be from 10 to 34. If this is my range, I can tell that my target is going to lie in this range only. So this is my possible row and I'm going to return this row. So from this row, I would get I equals 1. I'm going to get this answer from for a target of 24 in this matrix, right? I would get I equals 1 or 1 as an answer. So I know the possible row. If I know the possible row, can I just apply binary search on this row itself? Right? If I know the possible row, these are sorted numbers in an array. And if I know how to sort I know how to find a number in a sorted array, right? Using binary search. So I'm just going to apply a binary search on this row only. And this would be more efficient. So let's say let's take a different color. 10, 20, and 25, 29, and 34. Right? This is my current range. So my low is here, my new high is here, my mid would be here. Right? And my target is 24. Now my target lies on the left hand side. Right? So my high is going to be decreased by 1 or mid minus 1. Right? This would be my new high. So my high is here. Right? This is 0, 1, 2, 3, and 4. So my new mid is going to be 0 plus 1 by 2, which gives me 0. So this would be my new mid, right? If this is my new mid, I would check if this value is equal to my target. This is not equal to my target. So I'm going to increase my low. My low is going to be here, right? Because of mid plus 1. Low is going to be mid plus 1. Right. So if I would check that if 20 is equals to my target. Now 20 is not equals to my target, then I can just simply return false from here. I can simply return false from here. I can say that 24 is not an answer for this question. Right. Now we know the approach. Let's try to code this. Okay. So you just have to code this. Right. Now I have my Boolean search. I have this array or vector. Then first I have to check that if my row is possible. So possible row. Right. What is the second check I have to make? That if if it is a possible row, then perform binary search on that row. Right. So let's check if it is a possible row. And my possible row is going to be R. Right. And I would get that from binary search on row. I would make this function. I would pass this matrix. And I would pass this target. Let's copy this. Right. Let's make a function. Int. My function is binary search row. Right. Now I need my low and my high, right? My low is going to be my first row, or the index of the first row, and my high is going to be the index of the last row, which is matrix dot size minus 1. Okay, this would give me the last row. Now I also need the last column, because I am going to check between the target between 0 and my last column, right? I'm going to check for that range. So matrix 0 dot length dot size minus 1. Okay, this is my last column. Let's perform the binary search on my row. So this is low is less than equals to high. Now while this is true, I will make a mid, which is low plus high by 2. Okay, now if my target is greater than equal to my matrix of R, or my matrix of mid comma, now I'm going to check for that row only, right? And I'm going to check if it is going to lie between my range. So if it is going to lie between my range, so that would be between my target of mid of 0 and target is less than equals to matrix of mid of my last column. Okay, if this is true, I'm going to return that mid, because my mid is the possible row at that point. But if it is not true, what can be the other case? That if my target, okay, so let's see, let's say I have this row, I have this matrix, right? And I am at this point, I'm here, right? My mid is here. Now my value is, let's say, I know that my value is going to lie here. So what is the check that I'm going to make? I'm going to make the check that if my target is greater than this, right? My target is greater than this block. Because if I make a check that my target is in between this, so what I'm actually doing is, if this is my mid, and if my target is lies between in this range, I would return that to be the possible row, right? If I say that it is greater than this value, it is greater than this block value, then I will just check in the bottom hand side. And if I say that it is smaller than this value, then I would just check in this side only, right? So I'm just doing the same thing here. Okay, if my target is greater than matrix of mid and my last column, if this is true, then my low is going to be mid plus 1. Else my high is going to be mid minus 1. Okay, I would get my mid from here, and if it doesn't, and if the target is greater than mid of LC, then my low is going to be mid plus 1, else my high is going to be mid minus 1, right? After this while loop, if this while loop executes and I don't get any mid, that only means that I didn't find any range in which my target was present, right? So I would just simply return minus 1. Okay, and here if I in this part I would say that if my r is equals to minus 1, which means I just return false, because there is no value, the target is not in any of the ranges, it does not lie in the matrix itself. Okay, so I've performed this binary search row, I've got this row, and I have to perform binary search on that row. So I have to perform a binary search on that row. So let's make a flag boolean, and it will be a binary search, and then we'll pass a matrix, the target, and the possible row, right? Binary search function will tell me if it is possible, if the value is present in that row. Okay, if it is present in that row, I'm going to return true, else I'm going to return false. Okay, so here I'm going to return flag. Okay, now let's make this function bool binary search, and my arguments are going to be this, right, and enter. Now I will make a low, which is 0, and a high, which is matrix of 0 dot size minus 1. And why is that? Because I'm checking in the range, right? I'm going to check between my low and high. Now what I'm doing is that I have this matrix. Let's say I have this matrix, right? And I have, let's say, this row. Now I have this possible row. Now I have to perform binary search on this possible row, right? So I will take this column, which is 0, and this column, which is my matrix of 0 dot size minus 1, right? So I'm going to perform a binary search on this low and high. Okay. We're here. So this is binary search row, this is binary search. Now let's run a while loop. While low is less than equals to high, and I will make a mid, which is low plus high by 2. Now, if my target is equals to my matrix of R comma mid, what does this mean? This means that for my possible row, if it is present in that column, if it is present in that mid, I'm going to return true, because that is a answer. Else if my target is greater than matrix of R comma mid, then it simply means that it is on the right hand side, and if it is on the right hand side, I will increase my low, right? So my low would be mid plus 1, and else it is on the left hand side, so my high would be mid minus 1, right? This is my while loop, and if it goes in here, it means that it has found the value. If it doesn't, then I'm going to return false from here, that it did not find the value or the target value. Okay, so this is my code. Let's run this. It is accepted. Let's submit this code. Okay, it is the right answer. I hope you understand this video. If you don't, I would suggest rewatching the part which you don't understand. Don't forget to like, share, and subscribe. Thank you for watching.